Hello, so this is the evening of the first day of the Chapter 4 lesson about quantitative data, graphing and summarizing. So this is an example, as you can see, of dot plots. So dot plots are very similar to stem and leaf and pretty similar to histograms in that they're another way to display very simply. It's probably one of the first ways you learned how to graph quantitative data, because each point represents a actual case. So in this case, what we're looking at here are the winning times of Kentucky Derby races. So we have the number of races and the time in seconds. Obviously, we can see it's 150 to 160. So 160 is probably in increments of 2, because this would be 152, this would be 154, 156, 158. So these are in increments of 2. So obviously, there are going to be races that would probably be like, 151.8. Some of them would be 152.3. They're putting them into minorly bigger categories by making it rounded a little bit some more simply. So real quick, just to show you what might be interesting to you, I don't know, is that there's a big gap between the different times. There's a gap. It looks as though we have a highest number of around 134. And then we go all the way without any data until around 154 seconds. Just so you know, this was about 100 years ago. And the data on the bottom was more recent. What is more recent? Less than 100 years ago. So a dot plot will give you every single case showing, versus a histogram, you're not seeing the individual pieces. The histograms peaks, the maximums are going to be representing how many total frequency there are, but we can actually count them here. You may see the data displayed horizontally, which is what we're seeing here, or you may see it vertically where the data is going up and down. Both of them are fine. So let's answer 2 questions. The first question, grades on a math quiz. So this is a math quiz out there. How many students took the quiz? Answer the question. Okay, if we were going to answer this, we would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we had 13 students take the quiz. Let's see the next question. Next question, how many students scored at least a 60 on the quiz? So we're looking for 60 at least or better. So we have 1, 2, 3, 4, 5, 6, 7. Before we draw, we want to think. We do want to make a picture, but we have options now. I will tell you in this class, the majority of our graphs are going to be histograms. Histograms are a nice summary. You can have lots of data and be able to quickly see the summarized data in the picture, versus a stem and leaf and a box plot, which are going to give you each individual case, being able to see them on the page. The stem and leaf, you're actually going to see the numbers. The dot plot will have the case being represented by a dot or an X or whatever is being done. Before we do this, you have to make sure that the quantitative data condition is being met, meaning that the data is quantitative, that is numerical as opposed to categorical. Now, the last thing I wanted to start with you today is bringing out the idea of how to discuss, how to talk about the quantitative summary graph that you're going to see, the histogram, for example. When we're describing distributions, and it'll say, describe the distribution, that's what it'll say. You want to make sure to always tell us 4 things. I crossed it off and I wrote 4. We want to talk about the shape. We want to talk about the center. We want to talk about the spread. And we want to talk about anything unusual. So let me talk to you about what I would say about this next graph so you have an idea about what we're going to talk about tomorrow. Okay, so we have center. Oh, the way I want you to remember it is center, unusual, shape, and spread, or cuss. And we say no BS, or with BS, be specific. Cuss and BS. Be specific meaning in context. If it says to compare, you want to use comparative words, greater than, less than, as well as the number you're giving. So this picture of the earthquake, let me tell you what I would say about it. I would say that its shape is unimodal. Its shape is roughly symmetric. I would say that its center is around approximately 7. That would be fine to say. Approximately 7. I would then say that the spread looks to be from 3.0 to 9.0. So 9.0 minus 3.0 is 6. It's going to be the range. That's my spread. We could also do things where we're trying to figure out approximately what the inner quartile range is. We'll talk about that later. We don't need to. And then I would talk about anything unusual. So what is unusual? Specifically, what's unusual is anything that's an outlier or any areas where we would want to draw some focus to the information. In this case, I would say that what's unusual is it looks to be a small number of earthquakes at 3.0, maybe that might be 3.8 maybe. And I'm not sure if there's any others, okay? And so at 3.8 at approximately, maybe I'd say approximately 3.0 and 3.8. That's telling me that you know there's something unusual. There's also, what's also unusual is there's no data, no earthquake data from 4.0 to 5.0. Again, that's interesting. It's unusual. So anything that seems interesting, we would talk about. Okay, we'll talk about this more tomorrow. Have a wonderful evening.